Hopefully we're streaming.
Guys, so I get you to grab seats. So you want to get started in a couple minutes?
So he's pretty good, but
Cool.
the biggest thing we
Excited?
found about
There we go.
clean data, clean. So data analytics, data group is huge. Doesn't work usually pulling results are all that shit. You know what I mean? I call this, so it translates data, send it over. You know what I mean? So you learn a lot how to transform the data. That's where the data science is. That's where actually kind of what this kid is. He has that mindset to get a junior for him as well. So
Oh. Don't people do like
Cool.
Airbnb?
Looks like it actually worked.
That's what. Yeah. There's also people from UMD, so they like.
Oops. Yeah. This window. All right.
Guys, thanks for coming. So just real quick about me and about like what we're actually doing here. So you're in the right place if you're here for the Frederick .NET Meetup. Hopefully you guys everybody's will be able to see this. I'll zoom in, as necessary when we get into kind of some more live coding. This is I've told a couple of you guys this is more or less just kind of going to be like an ML.NET or a machine learning show and tell, as documented by my learning process, just kind of what I've been through so far. I'm a .NET developer. I'm not by no means a data scientist. So if anybody here knows more than me, please tell me. And if you have any feedback on how this compares to kind of like other machine learning libraries that you've used, I'm certainly interested in hearing about that as well. I'll try to keep this to about 45, 50 minutes. It's the first time giving the talk. My slides are even partially incomplete. Yeah, we're going to learn about ML.NET. Just a quick quip about my intro slide that I'm very, very proud of. So the idea behind this, we're not going to get into a bunch of different machine learning algorithms. We're just going to talk about regressions tonight using a couple different trainers. We'll get into some more of the vocab as we get move along in this too. But we're just going to be doing some regressions. So what's a regression? If anybody remembers from like, I guess, Algebra 2, when you're in middle school, high school, whenever, your line of best fit. So in 2 dimensions, when you just have an x-axis and a y-axis, your line of best fit is just kind of an average throughout all of your data points. When that starts to multiply throughout different dimensions, it gets a lot harder to conceptualize visually. So that's just primarily what we're going to be going over tonight. I'm going to go through a quick example that I already have that's running just to show you roughly what the output's going to look like, so that I don't set any unfair expectations, and that also you guys don't have any high expectations of me, because we're not actually going to be doing anything like crazy fancy tonight. But it's pretty. Hopefully, you can see the power of the library after this. If you did have some much larger data set, we're going to be dealing with a couple reasonably large data sets. But in terms of machine learning, the data sets are kind of small. Typically, you want very, very large data sets. The more data, usually the rule of thumb is the more data, the better. Not necessarily always the case, but sometimes. So this is the normal slide that I start out with. My contact information. This is the Frederick .NET Meetup. Thanks everybody for coming. This meetup wouldn't be possible without the company that I work for, iHire. So we're a job board in the niche space. We run about 56 different talent communities across lots and lots of different industries. The one you guys, if anybody here is familiar with it, it might be ihiretechnology.com. But we run a bunch of other niche sites in every industry you can imagine. ihirenursing.com, ihiresalespeople.com, ihirewhatever.com. We differentiate ourselves from other boards by providing a much more niche experience as opposed to kind of a general board. They both pay for my meetup fee in addition to the pizza and sodas that we're having tonight. We actually have like a little like iHire fan club kind of back here and a couple other folks. So thank you for my coworkers for coming and showing your support. We're also hiring. This is not the extent of the positions that we're hiring for right now. This just happens to be 2 of our dev positions that we're actively interviewing for right now. An intern, which should just kind of have a love for technology and want to potentially get into the .NET space, or a software developer 1 kind of entry-level position where ideally you have some web development experience already. If anybody's interested, please, by all means, I'm happy to give you a card, anything, just kind of ask me questions afterwards. Love to point you in the right direction. We're also hiring in our marketing department, and we're also looking for a talented product director right now. So if you know anybody, point them my way, and I'll be forever grateful. And we have our obligatory Fitzy slide. Kathy would kill me if I didn't do this. She's the CEO here at Fitzy. It's a government subsidized accelerator that I talked to some of you guys about. It was a Jan Gardner vision from a long time ago. And this is kind of the technology, the specifically technology wing of the company. So they started over at their location on Metropolitan Court, more focusing on specifically biotechnology, whereas now there are a bunch of businesses that are actually right behind this wall, all the way in the back of the building and elsewhere in the building, that Kathy and her crew kind of help. So an accelerator will give you access to their legal, financial, accounting resources, all of that kind of thing. And she also wanted me to mention Tech Bash. Does anybody happen to know or have heard of it, or know if she already has something in her newsletter? She keeps asking me to promote it. She wants it to kind of be a free services or product exchange type festival where it would be ideally hosted right here in this space and maybe even spilling out onto the street. If you're a tech company or work for a tech company in the area, come and showcase your stuff, whether it's what you're selling, what you're selling to subscribers, or whatever it is. So keep an eye out for that. And again, Meetup also would not be possible with this many people, at least, without the use of this space that Kathy lets me use. So be nice to it. All right. What is machine learning? So everybody is here because you're at least interested in machine learning. Buzzword, real thing. It's a term that's thrown around a lot. A lot of people are just trying to check a box, and maybe they're not actually doing machine learning or artificial intelligence. They seem to kind of go hand in hand. I guess ML is kind of the umbrella term, and artificial intelligence kind of is one type of machine learning. So it's a data science technique. We're trying to forecast data. You're trying to make some kind of prediction. You're trying to answer a sharp question. And at its core, it really only answers 2 questions, but you can kind of break them out into 5 different questions. Is it A or B? That's a classification algorithm. Is this weird? Some kind of anomaly detection. So is something outside of the norm, of my preset parameters? Has the temperature gone too high above in this room for too long a time? How much or how many? That's what we're going to get into tonight. So kind of extrapolating based on existing data to make some predictions. How's it organized? So that's an unsupervised machine learning task, which we'll touch briefly on some of those vocabulary words in a minute. Given an algorithm a set of data and have it kind of make its own inferences, is what you might use something with clustering for. So if you had 100,000 pictures of cats, you might want to identify the species of cat, or something like that. Or maybe you just have 100,000 pictures of animals and you want to figure out which ones are cats. Or what should I do next? Reinforcement learning. So all of them really fall into, or are all really guided by one principle: asking a sharp question. So not trying to let machine learning do everything. Some of the work that we're going to talk about tonight, getting things set up, it takes a lot to get things ready. Getting the data ready in the state that it is, the state that it needs to be in, is so much of the challenge. Your data is inevitably going to be in some convoluted form. It might be in 50 different sources. It might be different encodings. It might be different databases. Some of it might be on paper. You might have missing fields, all kinds of different things. So probably 70% of the effort that I've put into this presentation was really just kind of grooming a couple data sets that I found online that were in a data set repository that still weren't in the state that I would have liked them to have been in, where I could just feed them into this magic box and have it make predictions for me. So we'll get into a little bit more of that as well. All right, our key concepts. So I'm going to use some words, and I already have used a couple of the words, and I just want to make sure everybody is on the same page when I say a certain word. We already talked about regression. So there are lots of different machine learning algorithms. Regression is one of them, where, again, we're just trying to make a prediction. So given a scatter plot on your your Cartesian plane that I talked about before, if you have a bunch of data points and you try to make a line of best fit, and you want to make a prediction in the future for some x value, you can predict the y value based on that. as we move into more, that would be if you only had one independent variable. In this case, we're going to have lots of independent variables, so we need to. It's a lot harder to conceptualize visually and even kind of logically. It gets increasingly difficult to kind of hold it in your head. It's kind of like if you want to think of it another way, kind of think of like we have our 3 dimensions of space plus our time dimension. Then what happens after that? Imagine if you had to add more dimensions onto like our physical world. So that's the kind of thing that we're going to try and represent with some of these. If I say feature or category, I'm going to use feature for the most part, but our categorical data, basically our inputs. All right. So one of the first sets of data we're going to look at is a wine quality or a wine review database. So I've got about 120,000 data points that look like where a wine came from, what it's called, the description of it, how much it costs, what region it was in. The data set even had like the sommelier's Twitter handle, things like that in this data set. There was some of it that was just really unnecessary. But I'll show you how easy it is to try and include that data and rerun the regression and figure out if there was something relevant. Maybe there's always one particular sommelier that is always rating things higher on average or something like that. ML.NET even has some tools where you can kind of look at your independent variables individually and figure out how they might be affected if they were filled with, say, random data or even missing. So ML.NET, is a rapidly evolving library in the .NET space that there's a lot of, I hesitate to say black box. It's black box to me because I don't necessarily understand some of maybe the higher level math that's behind it. It's an open source project at this point, so you can see all of the source code that you want to, even make pull requests, and if they're approved by Microsoft, they'd be in the next version of the code base. But even since I started planning this particular presentation, the ML.NET library has gone up 2 versions, 2 minor versions. It went from 0.9 to 0.10, and as of I think a week or 2 ago, something like that, it went up to 0.11. And even with those minor updates pre-GA, there's been pretty significant changes in the API. So even like the 0.10 and versus 0.11 code, there were breaking changes. In any event, if I say feature or category, I'm using them interchangeably, and it just means some of the stuff that we're inputting. If I say label, that means the prediction. So that's just kind of a general blanket terminology that ML.NET uses when we're talking about the field that we want to predict. So in the case of the wine data, the field that we want to predict is the quality score, which is something I think from like 1 to 100. I don't think there's anything below like an 80, so it's basically 80 to 100, but that's going to be the label or the score. And in the diamond exercise, so we have a bunch of different features of diamonds, so cut, clarity, color, all of that kind of stuff. And our label that we want to predict is going to be the price. So given a set of inputs given a set of attributes for a diamond, we want to predict what that diamond might cost based on this data. A transformer, so moving a little bit further down into the actual nitty-gritty of the code. A transformer is basically something that exists in the ML.NET library that takes your inputs and it outputs the predictions. I know that I basically just read that off of the slide. The interface is actually a lot more robust than that, but that's usually the type of model that you pass around to your different functions, whether you're training a model, building a model, or trying to make a prediction from a model. An estimator is another term. We're only going to touch on that briefly, but I wanted to put it in here. That's just something that actually learns from the data. We're going to use that when we're actually building and training our model before we actually try to make predictions. And we've already talked a little bit about data curation. That's going to be a little bit of the hand wavy tonight. I mentioned that there was a lot of time spent just getting the data in the state that it needs to be in. So I'm going to open up an Excel spreadsheet. We'll be able to look at the columns, and then we're pretty much just going to close it and go straight into coding. I just want you guys to see that like the data's there and approximately what it looks like. All right. So if you're following along, I put something in the meetup notes. You're welcome to try to. I'm going to be live coding this, and hoping that everything goes well. But the only things you actually need to get started with this, everything here is 100% open source. The .NET Core SDK, we're going to be running on version 2.1. Your mileage may vary if you happen to be on 2.2, which is the current. I don't know if 2.2 is GA right now or if it's still in some kind of preview. I think it's out. So if you install .NET Core SDK, you might get version 2.2. You'll need to specify that you want to use 2.1. because there are likely to be breaking changes. Visual Studio Code is going to be our choice of editor. We're going to do some stuff on the command line, and you're not going to need Git or anything like that for this. This is just kind of one of my default slides. So we talked about regression already. This is the scatter plot that I was talking about. So this is the two-dimension, one independent variable, one dependent variable. So when it looks like this, it's very easy to see that line of best fit. When it moves into more dimensions or more features, in the case of machine learning, then it starts to get a little bit more complex. This data right here is actually still only representing 3 dimensions, not even quite 4. The blue circles represent, this is just a random picture I pulled offline. The blue circles represent our data points, and then the wave function, that you I don't even know if that's technically a wave function. Again, not a data scientist, not a mathematician. That's basically representing the line of best fit or the plane of best fit, whatever you want to call it. But just try to imagine what it might look like if you try to add additional dimensions. I've seen some functions like this that might be colorized, where you might be able to try and conceptualize another dimension of a feature, but you're really not going to be able to go beyond that. So just with our diamond example alone, we've got 10 different features that I think it's 10 different features that we're going to be using as input into our machine learning algorithm. So it's not really something that can be represented in classical 2-dimensional paper or even in 3-dimensional space and still really makes sense. All right, so this is just a real quick. I mentioned the diamond data set that we're going to use when we actually go through this. So it's just a CSV file. So there's nothing magical about this other than the fact that it was in terrible shape when I got it. I believe I got this data set from, I think I got both of them from Kaggle. I don't remember specifically. I think I note it in my final slide. There's lots of data repositories out there. Kaggle.com, Kaggle, is a pretty big data repository or data repository, however you want to say that. That has all kinds of random, sets of data. They might have like information from the World Bank about different countries and their economic data. You can go to all kinds of other places, Bureau of Labor and Statistics.gov, and find information on our own economy or other countries' economy. Just the idea is basically I was just looking for some data that I could make sense of and demonstrate to some people using some basic regression. And we'll look more into that data after that. So I'm going to take my seat now. We're going to go look at an example first that's already working, and I'm going to zoom in here so you guys can at least see a little bit. So this is nothing more than just a .NET Core console application, version 2.1. There's not a lot to it. I've got a program class, a handful of Microsoft.ml namespaces that I'm using. I'll go into a couple of these briefly, but I don't know if they're going to be really useful. After that, we go straight into the code, and you can see there's really not a lot of code to this. So this is a wine quality prediction data set that I found. I believe this one was on Kaggle. I've broken the data down into 2 different sets. So with regression algorithms, with machine learning algorithms in general, you want a training data set, you want a test data set. So I took the 120,000 data points. It started at like 150, and then I started grooming the data down for missing cells and things like that. I broke it down into, I think, 100,000 and 20,000 for my training set and my test set, respectively. The training set is what you use to build your model. The test data set is what you're using to validate your model. And so based on what you learned from the training data set, how accurate were your predictions? So if we look at this, again, nothing fancy. It's just a comma-separated value file full of information. So acidity, some other type of acidity. I don't even know what these things are. If anybody here is a wine connoisseur, feel free to chime in. Just a bunch of different data points, and the one on the far right is the quality score. So there's a bunch of 6s up here. We got a 5, a 7, an 8, things like that. So based on all of these different dimensions, I wrote around 50 lines of code or so, and that is this. Some of this is really just infrastructure. The actual meat and potatoes of it is just building the actual model and then evaluating it. And then I even have some extra bits in here that give us some more information that I mentioned earlier. So knowing that this works, before we actually dig into the code, I'm just going to run it.
We're going to get some output down here in a second. There's actually going to be a lot of it. Can everybody see this okay? Can anybody not see this on any TV that you can see? Great. So with larger data sets, obviously this will take a little bit longer on the average. So there it saved our model.zip. This is nothing more than just, you can think of this as a black box for purposes of this presentation. This is just the model that it just trained based off of a specific trainer. So we had a 0.25 r squared. What does that mean? So if I flip back to my slides and come back to here, if you remember from your Algebra 2 class, your r squared is basically, you can think of it as the sum of all the vertical distances from the data point to the actual line. So they should even out with your line of best fit. So the closer that number is to 1, the better your regression, or the more correlating your regression is, or the further away, closer it is to 0, the worse your data is. So surprise, surprise, just an initial data set with minimal grooming. We didn't come up with a very high correlation using all of these fields. The other data that we're getting up here with each individual field minus the last one for the actual quality prediction. This is another feature of ML.NET that I just found, I think last night or the night before when I was putting this stuff together, and it was basically one line of code. I was like, well, it was more than one line of code, but it wasn't difficult code. It basically reruns the data model with, it tells you what the r squared would change by if this field, whichever field is on the left, were filled with random data. So it kind of gives you a feel for which fields are important and which fields really aren't that important. So we can see that our fixed acidity right here would only drop it by 0.08. Now, while 0.25, if you lose 0.08 from 0.25, that's arguably significant. You can see that the alcohol factor was much more important in terms of the actual wine quality. This would actually take it into a negative. Again, we're not going to get into the specifics of why a negative correlation is bad. So that's the little bit of hand waving that I mentioned that we were going to see in this presentation. So this is just a kind of a sample of some of the output that we're going to get.
Is there a name for that variance?
For what?
Is there a name for those type of variances there?
I'm not sure. I can show you the code that does it.
Right. I don't want to interrupt you.
No, that's okay. This is by no means like a lecture. If people do have questions, and we can't, if I can't answer them quickly, then we'll try to move on if I can. But this is it. It's the permutation feature importance. So you basically pass it in a couple features of the model, tell it what fields it needs to look after. This is nothing more than a link statement that says go into my data and just pick out all the columns and select them and then just print them. So really, this is the only line that actually does that work. So permutation feature importance, or PFI. I think I saw that acronym a couple times, but that's loosely what does that.
That answered it. Thank you.
Cool. There's one step that I think got skipped here. Well, we'll come back to that. In any event, that's the entire program. The only other file that's even really relevant in this project that technically wasn't generated for me by .NET Core was just this class that describes, this model that just describes what's actually in my data set. So we looked at the CSV, the train data and the test data are they're not identical values, but they're identical schema. This class just represents, is just what I want to call these fields. And I specify which column in the CSV that I actually want to load. So you can skip columns if you don't want to groom your data fully. With extremely large data sets, you might run into actual like file IO limitations. So keep that in mind with extremely large data sets. If you're doing some kind of analysis on petabytes of data or terabytes of data, your mileage may vary. We're going to be dealing with smaller data sets tonight. All right. So what we're going to do next is we're going to take a look at some diamond data that I'm going to try and pull up here. Again, this data has been groomed. I'm going to try and pull it up on your screen here in just a second. This one, the diamond data set was, I think, significantly smaller. I don't remember the exact row count. We'll look at it in a second here. I'm just trying to pull up. I didn't have my Excel window open. So we'll pretend that this was like that 80% time that I actually spent grooming this data. So we already got a screenshot of this. If you guys can't see this, sorry. Maybe I can zoom in a little bit. Or not. Caret, cut, color, clarity, depth, table, price, and X, Y, and Z. It took me a while to figure out what these actually were. This was an actual like physical measurement of the diamond, I guess at its extremes. I found out, and we'll get into that once we actually start coding this. These were actually not statistically significant. They had very little influence. They actually influenced our model negatively. It's entirely possible that I did something different. Yeah, the physical size of the actual diamond based on everything else. It's entirely possible. I will concede that I did something else wrong to create that anomaly, but that is something that I observed, but we'll be able to see quickly how to regenerate the model really, really fast when we go through this. So we can take a quick peek down here. So this one is 44,000 data points here, and is that 44,000? Yeah. And then the test data set, I think, was probably around 10% of that. So our validation data set, I think, is like 4 or maybe 7,000 is ringing a bell. So a little bit less than the wine data, but it was still enough, to make a decent prediction.
So do you have to kind of tell how much of a data set you need, or is ML.NET smart enough to determine its own, hey, you probably just need this based upon the data quality?
Good question. This is more or less just a rule of thumb, as I understand. If you have a more intrinsic understanding of your data set, I'm led to believe you can probably make a better decision on how much data you need to train your model versus how much you need to test it. I've seen lots of estimations on places like Stack Overflow and Kaggle and elsewhere that are like 80-20, 90-10. The general consensus is more data is better. The larger your data set gets, the smaller your test validation data set can be. So I was just going with something between 80-20 and 90-10. But as far as I know, there's nothing in ML.NET at least yet. Maybe there's a feature request out there that I'm not aware of that will just take one data set and you can send in a parameter, say 20% test data set, and it will just do that kind of thing for you. I think the reason it probably doesn't do that at this point is because of the granular control that we're going to see in a minute, where you have to manipulate the data in certain ways if it's not numerical, for example. So the ML.NET library deals best with numerical data. So to be able to plot something on a graph, you can't very well have a string of text. So even if it's a single letter, or like in our whatever this H or VVS2, I think one of these is the clarity, one of these is the cut, or whatever it is. We're actually going to see how to translate these, how to kind of vectorize these into numerical data that ML.NET can handle. All right.
Question.
Yes.
How do you know how to split the data? Like, do you do it randomly?
So this data set, and it's entirely possible, this is actually a good question too. So it's entirely possible that this data set may have been ordered in a poor way that I did not see ahead of time. And I just split it at the end. I took the bottom 10%. I noticed that there was nothing that was in order for me here. It actually starts this way, but it quickly changes. I thought maybe the caret weight or something like that was different, but then I see it, I spot checked it, but I did not do any like hardcore digging. Again, that's some of the hand waving magic in data curation that is probably potentially some of the reason that my prediction is not going to be very, very accurate. It'll be ballpark, but it's not going to be extremely accurate. I don't know if that's a consequence of not having enough data, or maybe just like you suggested, it might just be poor data distribution. It may not have been ordered. Maybe it should have been ordered randomly, to get the correct split. So that's a good thing to point out. Thanks for that. All right, so we know what the shape of our data actually looks like at this point. So at this point, I'm just there's no magic here. We're going to start from the actual beginning. So if anybody's familiar with the .NET Core SDK, it has a really powerful command line. This is just kind of this part is muscle memory for me. As far as anytime I need to test some C# code real quick, I will generate a new console really, really fast and kind of go from there. So we're going to say new console, and we're going to call this diamond quality prediction. This is just going to do nothing but generate a new console for me. I'm going to change into that directory. You can see not a lot there. A CS proj file, that's just the .NET file, basically, that kind of dictates what kind of things to include in the project, what the target framework is, that kind of thing. I guess I should have started with the caveat that like a little bit of understanding of .NET Core might be required, but we're not going to touch on it too much. and we have our program CS file. The only other thing that we need to do is add the Microsoft.ml NuGet package. So we go here. This is going to add the latest version. I'm going to spot check this to make sure it actually adds 0.11. And, whoops, crap. It did. Perfect. So I'm looking at this down here. So if this changes to 0.12 in another month or so, as it's likely to do, probably even sooner, your mileage might vary. It's entirely possible that with the rapid evolvement of this project, that the API is going to change, even to the point of changing function names, parameter signatures, all kinds of stuff like that. All right, so the next thing I'm going to do is just open up my project in another instance of VS Code. So I'm going to come over here, start a new window, repos, meetup ML, and we're just going to open this folder. This is just my editor of choice for the moment. It's going to prompt me to install. I'm going to give us a color. Okay. I'm going to install the C# extension. If you guys aren't familiar with VS Code, I can't recommend it enough. It's a phenomenal editor. It's crazy extensible. And there really aren't any more languages and platforms and frameworks that it does not support. It's everything. You can do Ruby on Rails development. You can do COBOL programming in VS Code. If that really strikes your fancy. There's extensions for everything for VS Code, and it's like lightning fast as long as you haven't really bogged it down with a ton of different extensions. Okay, so we're going to create a data directory, and we're going to dump our data files in there. I think I have those handy. Let's see. I think I can just copy them from here. Let's see if this works. Oh, that didn't work. Sorry about this, guys. All right. I wonder if this will work. All right, so this is just where I want to store my stuff. If you remember from the other project, this is where we're going to see the actual model.zip file get generated after the fact. So at this point, we can start coding. We don't need our hello world line. We're going to make, as we need reference to the various Microsoft namespaces, the ML.namespaces, I'm going to use the command dot keyboard shortcut just to show you guys when they're needed and why, because we're going to kind of go through this in a couple phases. So at the first, I'm actually going to copy and paste this code because it's really remedial. I'm just creating a couple data directories so that I can use them later in my code. So all I've done is create a couple string variables that have some paths. So this is nothing more than just describing This is just describing where my actual data files are located. And I'm trying to add system.io so that I don't get a little red squiggly. That's a technical term. So this is nothing more than just describing where my CSV files are and where I want my model file to live when I start generating it a little later. So if anybody's familiar with Entity Framework, I know that some of my fellow devs at iHire are going to be. Entity Framework is just an ORM that you can use to talk to a SQL Server database, for example, in a .NET web application. Similar to Entity Framework, there is a machine learning context that we're going to use pretty heavily in here, and it is not surprisingly called ML Context. And I knew I was going to do that because I didn't include all of my things first. So we need the Microsoft.ml namespace for this. And in the interest of consistency, we're going to create this in a deterministic environment. So we're going to put an actual seed in there. If you leave set seed as null, then it's a non-deterministic environment. And the ML.NET library will treat that accordingly. I don't know how much randomness is actually introduced in the fast tree trainers that we're going to be looking at, which is just the regression algorithm we're going to be building. But if it does, then we would see different results each time we ran this. So that's just why I'm starting with that. The next thing we're going to do is we're going to build our model. Yeah, we're like actually already there. So we're going to make a method called train, and I'm just going to pass it in the context and my train data path. I'll come back here and have VS Code generate a little method for me. And I want this to return one of those transformers for me. Transformers. and I have my context and my training data path. I have my cheat sheet down here, so I apologize for that, but it's gonna help us get through this. I'm not quite at the time that I wanted to be at, so we're gonna go from there. What we need to do is create a data view. So the data view is basically load all of this information up. Even in just the most recent version of the ML.NET library, this was create a text loader, load up all my fields, describe their data types, all of that kind of stuff. That's actually changed pretty dramatically in the 0.11 API. So I have something called a data view, and I'm going to load this straight from, it even has a load from text file. If you have a CSV that's already been there, just trust that this is going to work. It will accommodate for some of like the common, some of the known deficiencies of CSV files, because it is never as easy as just opening up a file and splitting on new line and the commas. This will handle fields that have commas in them. It'll address a lot of that stuff. We're going to load up our training data path. The second parameter is our list of columns. Nope, I'm sorry, we didn't even need to do that at this point. We just need to tell it in this first, no, I'm sorry, I've missed the actual type is what I missed, which was the diamond class that we are going to write here in a second. In the wine data set that we looked at a second ago, we had that wine quality class, I think it was. So I'm going to copy and paste the diamond file from my other project in the interest of expediency. So let's create that real quick. And then in here, we're going to do the train data path. And let's see, there is a has header bit. And there's also the separator. And that is just a comma. And I think I need to actually, I think I might need to call this guy out. Is this guy's source path? No. What is that guy actually called? Sorry about that, guys. Like I said, what could possibly go wrong with live coding? Let's see here. No, because it's the locally scoped parameter right here. Otherwise, you would be spot on. I'm just trying to find my mouse and come down here to my cheat sheet. Oh, jeez. You would think that I would have. Yep, there we go. That was just the off part. Just that equal sign there.
First day.
Yeah. All right, so we're going to create a quick C# class. Nothing spectacular here. This is nothing more than just a plain old class object. It describes our caret, cut, clarity. So these are our string fields. Sorry, caret was a float.
To interrupt it, it automatically created that one, correct?
Sorry?
It automatically created that class for you?
No, I actually just copied and pasted that from here, but I just wanted to do a quick code review so that I'm not waving any hands unnecessarily. There's nothing staggering about this. This is just nothing more than just a C# representation of an individual row in our data set. So we have some strings and some floats. The floats are going to work out of the box. The strings, as I mentioned earlier, so the cut, color, and clarity, we're going to have to vectorize, which we can do with basically one line of code. It's a little lengthy, in my opinion, for what it actually does, but it should get the job done. For later, oops, I'm going to leave these back in. I told you that the X, Y, and Z, the actual physical dimensions of the diamond, didn't have much to do with it. And later we're going to use this diamond price predict object, which is nothing more than just an identifier for the label that we're actually trying to predict. So here are all of our categories / features in our diamond class. And at this point, cool. So VS Code recognized my, my diamond class. So this is doing the work that even in the most previous version of the API could have been dozens of lines of code, all basically in one arguably long line of code. I'll try to indent things for you guys as we move along so it's a little easier to read. The next thing we have to do is build a pipeline. The pipeline, now that I think about it, should have been on that vocabulary slide. But the pipeline is basically telling ML.NET, here's the order in which I want you to do these things. So these are the column names, these are the vectorizations that we just talked about with the string data, but here's how we actually input it. So we'll create a new pipeline, and there's something on the transforms object. We start out by copying the target column. So our input column name is going to be, this is the diamond exercise, so this is going to be price. And the output column name is label. This right here is a convention of ML.NET. I'll try to indent a little bit so we can see this entire line, because we're actually going to chain onto this line a lot. So this right here copies the input column to another column named as specified. I don't know if that's it's probably an upcoming change. This label will probably end up being hard-coded. It seems to just be a convention that I see everywhere, and it's also what ML.NET uses internally at the moment. At this point, the only thing left to do before we actually say, okay, here's all my floats, is vectorize or encode our string columns. We had 3 of them, so at this point, we're going to encode our string data. We're going to chain onto this. So this pipeline building is a very, very fluent syntax. Something else on the transform object, categorical. This one hot encoding is yeah. I thought that was hilarious. It doesn't seem like that is actually going anywhere. I don't know where it came from, and I didn't bother to look up the Git history, but I thought that was pretty cool. You give it the input column name. In this case, it's going to be cut, and then you give it an output column name that we're going to reference here in a second, and we'll just call it cut encoded. And in the interest of speed, I'm going to copy and paste that 2 more times because we have to do color and clarity, and then we also need to change the names here. Color encoded and clarity encoded. All right. We're going to keep chaining onto this thing. So at this point, we've vectorized those strings into some type of numerical data that ML.NET actually likes. And what we need to do at this point is append our we actually have to create a single column out of all of our columns. So this is kind of where, this is something that I'm not sure I quite understand how it's done. I understand why it's done, and I'll try to explain that. So when we were looking at our 2-dimensional line of best fit slide earlier, it was X and Y. I think what this is doing is basically converting all of our data into a singular X so that we can predict a Y. So what we want to do is concatenate that into a single column called features. Features, and then it just takes a params string array of all of our actual features, including our encode features. So we'll do our caret, which is a float field, our cut encoded. We'll do our color encoded, our clarity encoded, depth, table, X, Y, and Z, hopefully. Cool. So again, what we've done is basically just shove all of that data into what I understand to kind of be the X in our line of best fit example. Get rid of this stuff, and you guys might be able to see a little bit more.
Instead of you manually going and changing the data for color and clarity, you're just letting ML.NET figure that out.
Exactly.
And that's convention?
Yeah, so the one-hot encoding is basically what does that. So convert a text column into a one-hot encoded vector. The vector is obviously numerical data in at its core capacity, and that's what ML.NET needs. So again, if it's this could be like an essay or a single character. It's just whatever that categorical data is. In our data, I think it makes a little bit more sense because, like, for example, this D column right here, there's actually only like 5 or 6 different values that are in here. So they could just as easily, for intents and purposes, be 1, 2, 3, 4, 5, 6. So however ML.NET does that is a little bit of the magical hand waving. All right, and the last thing we need to do is actually decide on a training algorithm to build our model. So once again, there's more in the context. This time it's in the regression object that's in here. So actually, I'll start by just showing you the IntelliSense here. There's a whole bunch of different things that you can start from here. So multi-class classification, binary classification, all of that kind of stuff lives at this level. We're going down into the regression namespace and even further into the actual trainers. And you can see there's a whole bunch of them in here. Fast forest, fast tree Tweety. I'm not sure that I can even begin to do justice to many of these. I remember Poisson distributions from a stat class I took in college, but I'm not even sure what I could tell you if I could relate that to a Poisson regression. So that's the asterisk disclaimer, not a mathematician, not a data scientist. We're going to be using a fast tree, but it's that easy to change out a different algorithm. And you can find out very, very quickly when you run it, you'll get a runtime error if that algorithm doesn't apply to your data set, for example. Like sometimes you might want focused distributions in certain areas, or you might want wider buckets, or just depending on how your data looks might determine how you actually do that. That right there is the core of what we're going to learn today about ML.NET. So that's kind of the stuff that I wanted to take some time to walk through each line and what it actually did. We're basically done at this point. The only thing we have to do at this point is say, go ahead and try and fit this data, that is, come up with that line of best fit, or that function of best fit, or whatever it is, and give us a model. And we get that straight from our pipeline object, we fit it, and we pass in the data that we loaded up. ML.NET handles everything at this point. This describes how it's going to do it, and then this line actually does it here on line 37. This is the line that will take just a little bit of time. This is just, you can think of this as like the schema for our model, and you can think of this as the actual model. This will not generate an actual model.zip file like we saw in the other project. We actually need to do that. I'm going to copy and paste that particular function in the interest of time. And I'm going to grab that from over here because there's not a whole lot that it's actually doing here. It's not doing much more than just opening up a file stream and saving it to disk. The reason I'm doing that is because I may want to do a bunch of different evaluations or individual predictions or batch predictions. So I want to have that model handy after I've done it. And then I would just, ideally, I would just comment out my train method or something like that at a later point. And time permitting, we'll see some of that. So you can see in here, there's nothing too daunting. It's just, here's the context, here's the model, load up a file stream, save it to disk, and then print out a little note. All right, so at this point, again, we have a model, okay? So we want to evaluate it. If we run this right now, it will generate a model, but we're not actually doing anything with it. Oops, I'm sorry, we actually need to return the model. Let's not forget that. That might be important. Okay. So at this point, we're going to output some text. So we built a model, but we want to know how good it is. That's what our test data set is for. So at this point, we're going to pass in our context again, and we'll also pass in our model. We'll have VS Code generate a method for me, and we will start there. So again, this is just going to output some text at the end after we load up our test data path. We can use the similar code to what we used before to load up a data view. And we get to use that handy-dandy single line function instead of a whole bunch of more complex things that I found out about like a week ago. Load from text file. We're using the same diamond class. We're not onto the diamond prediction class just yet. Why aren't you recognizing that? Maybe you're just giving me grief for now. I'm going to load my test data path. Has header is true, and our separator, and that's our comma character. Okay, cool. I liked the diamond generic there. Our model has a number of different methods on it. So when we talked about those transformers, here's where we're about to use one. So we're going to generate try to make an actual we're going to set ourselves up to make some predictions, I should say. Model.transform data view. Okay, so we can look briefly at this definition. Take the data in, make transformations, output the data. Note that data views are lazy, so no actual transformations happen here, just the schema validation. So this is just kind of generating or getting ready to do what we're about to do. Now we want some kind of metric or some kind of measurement to do some output. We want to output that R squared value that we printed out in the sample that I showed you guys earlier. So let's make a metrics object, and inside of the regression namespace, there's an evaluate function, which is coincidentally named the same as the function that we're inside of right now. We'll give it our predictions object. We'll tell it that we want to tell us what we're actually which label we're trying to predict. Above, we named this label, and then we're going to call this score. All right. At this point, we can start outputting data. So actually, I'm going to rip this from my code as well, since we're not doing anything terribly complex, just a bunch of console.write lines with some fancy stars around them. So right here, we're just outputting metrics R squared formatted and this RMS value. I don't remember what exactly this is. If anybody else does, I'm happy to hear it. I remember reading that the lower this number was, the better your model was built, basically. Sorry?
Root mean square, right?
That would probably make sense. That's not the R squared, right? Okay. I thought it was some kind of loss function or something, or root mean squared loss? I'm not sure. All right. At this point, we should be able to run this, assuming I've done everything correctly. So we went through building a model. Oh, sorry, my evaluate function ended up above where we actually built the model. So we told ML.NET how to build this model, and now we're going to evaluate it and see how good we were based on our test data. So we sent in our trained data when we actually built our model, and again, we separated that data out, the short discussion we had earlier now we're going to validate whether or not we did any good. And we're going to get some kind of R squared value, we hope. And I'm hoping that it's going to be the same, since I seeded my ML context with the same value as I did before. Hopefully we get that same 0.25, I think it was. I think that's what I was working on last night. I did some prep last night just to make sure that the 0.11 version still worked, and it was still the version that was installing when I ran .NET add package, because I've certainly been nailed at these presentations before, accidentally updating. I broke the cardinal rule before. I just updated something and didn't think about it. All right, cool. So again, I don't really have a good sense of whether or not this 405 number is good or bad. I don't know if that's with respect to the price that we were trying to predict here, but we have some correlation. I hesitate to say a lot because 0.49 is not very highly correlated, but it is at least correlated, and we know how correlated it is.
Would you say towards 1 is better or towards 0?
Yeah, towards 1
That
means,
doesn't matter here.
yeah, toward the closer you are to 1, the better your regression, or the higher correlated your data is, and the closer to 0, the less correlated. I don't think that we're going to have time, if I'm trying to wrap this thing up by 8 o'clock, to go in and look at go in and try to start like snapping fields in and out. I'm going to try to be respectful of the time for everybody, but we do want to try and make a single prediction based on a diamond. So if we were given a diamond and we were able to measure these cut clarity, color, all of that kind of stuff. I don't know how to do that because I'm not a gemologist, but if somebody were to give me that, we would want to be able to make some kind of prediction on price, particularly if we were trying to buy something like that, to know whether or not we were getting ripped off or getting a good deal. So at this point, we're just going to generate a diamond prediction, which just means we're going to instantiate a new version of that, a new instance of that diamond class. So we'll make a quick method, test a single prediction. We'll pass in our context. And I just noticed that VS Code, you have to go all the way back to the method to get it to generate your method for you. Visual Studio will let you do it even at the end of the line. And just in the interest of speed, I'm going to copy and paste some more code, more hand wavy magic. Sorry, guys. And we'll just do a quick code review here. We'll talk through what it actually does. All right. There we go. So now we can actually see everything. All right, so we mentioned that we saved the model.zip file earlier. So we saved that to disk. So this code right here is doing nothing more than just loading that model.zip. So again, doesn't matter what's in there. That's our trained model with our 0.49 correlation that we had. Our prediction function, again, so this is just it's turned into one line. I think in the 0.5 version of ML.NET, this was actually a lot more complex than it needed to be. We also added that diamond price predict class that I showed you guys earlier. That it's nothing here, just another plain old class object with this column name definition, and it's describing what we're actually trying to predict. In this case, we pass the model our context, and then we set up our actual diamond. This is an actual record that was in our data set, that was in the training data set even. So the actual value of this particular diamond was 2774. I don't know if you actually need to set this, but I just added this here for sake of having a line to comment and talk about, so that this is the thing that we're actually going to predict. After we do that, we take our prediction function, which has our model loaded up into it and our ML context. We pass it the daemon, and it gives us an output. And I need to include my globalization namespace just so I could slap a $sign in there. It's not actually doing anything crazy. It's just taking the prediction price column, which is a float, and outputting it to string with a $sign. Something was wrong with my culture info, and I was getting some odd character when I was doing this last night. All right, questions there, like while we're actually going to run this and see this prediction work. I know this has been like a lot to ingest, but hopefully you started to kind of see the power of this. This is what I wanted to do.
You said that diamond came from your spreadsheet and the price. But now
Yeah.
you're gonna see what the price is predicted.
So even though this was in the training data set, there's still some, black magic happening in the ML.NET library that's not saying, it's coming out with an algorithm. So it's not storing all this data and saying when this exactly happens. It's trying to find correlations between everything. So we're going to see in a second that this actually did not predict exactly. And I can comment out my evaluate and my train methods, because all I'm doing at this point is just testing my single prediction. And we're going to get some output like this here in a second. So it's going to load up our model from disk, and we should get a prediction line here. So you can see this one was pretty far off, but I mean, in the ballpark, considering not a lot of correlation. If we can change these fields as we need, but we did actually we leveraged ML.NET, we vectorized all of our data, and we made some type of prediction. My gut tells me if this data set would have been 500,000 data points as opposed to 50 or 60,000 data points, we might have got a little more accuracy. I don't know for sure that that's the case. I also just realized this is different than what I saw last night because of the XYZ. So let's take a minute here while we are just before 8 o'clock, and let's make a quick modification. Instead of passing in, so let's not define. So it will still load all this stuff up into memory, but if I just get rid of these fields right here, I'm going to rebuild my model without counting on X, Y, and Z. And I think, oh, what I miss? Thank you very much. So I think this prediction will get a little bit closer. This was just some of the playing around. I was going through and rerunning this a bunch of different times, just commenting out different fields to see if they had impact. I discovered that permutation importance, or what was it, permutation something importance, the PFI, whatever it was. They said that single line of code that was that thing I explained that had, yeah. So this one got a little bit closer, just maybe like $50 closer, but actually, oh, this one was a lot less, yeah. Yeah, but it did increase my my R squared. The data was slightly more correlated, and this number had dropped a little bit. I can't really necessarily explain why that is. This demonstration was kind of meant to be a very cursory introduction to ML.NET, which is here's some data, assume it was in the right format, and here's what you can do with it in really not a lot of lines of code. When we actually look at all of this, even some of our helper functions were just about 100 lines of code plus this plain old class object over here, which I think technically if we wanted to, we could shave that off by just loading it up via strings up here, where we actually load this from text file. So what we would gain here, we would lose here, or vice versa. So that was a lot, but I am just about at 8 o'clock. I think I was just under an hour. Questions, discussion, feedback, no subject is taboo. Thanks everybody for coming. That was what I had. Thank you guys. Anything I can recap for anybody? Like I said, so usually it's about 8:15 or so that I want to start kicking people out of here so that I can lock the door up by 8:30. But you're welcome to kind of hang out here. On occasion, I unfortunately am not tonight, but on occasion some people head to Brewers right next door after this for some continued technology discussion. Yeah, thanks to everybody again for coming, and let me know if I can answer any questions. Thanks. It was just a comment on my methodical approach.
The actual data used to generate the model, how many rows per instance?
So the question was how many rows were actually in the data. I think it was around 60,000 total. The training data, I think I split down to the 44,000, and I think there were so a little bit less than 55,000, 52,000, something like that.
On disk, that zip file, can you typically use that there?
Yeah, sure.
How big it is too.
We absolutely can. Let's look at this in Finder. 85K.
85K is the zip file.
I've never actually looked inside this. What is actually in this thing? Training info, transformer chain. It just has a version file. Model key. Some different transforms with model keys. Yeah, I'm not, unless we started like digging into those actual files. Yeah, it's been black box for me, just kind of coming in with this like show and tell. But yeah, 85K, whatever that is, describes the regression algorithm that we use with the fast tree. If we wanted to rerun this, I mentioned before, it's just that one line. So if we wanted to try this with the fast tree Tweety, which was just some other type of distribution named after a guy named Tweety and another guy named Long, I think. Data scientists in the room might know, or almost certain to know more than I do about this. But if we run this guy again, it's just that easy. Change out the trainer and see if you get different values. Again, that time might not be trivial with really, really large data sets. I think this data set was pretty small, all things machine learning considered. But it's easy enough. Oh, it actually got pretty good. 0.67. So correlation went up just by changing that, and our prediction got even a little bit closer. So whatever the differences are between that algorithm and just the regular fast tree, I can't really do it. I'm not the person to describe that to you right now, but maybe in future talks I can try and learn a little bit more about that and help educate you guys. Or maybe you guys can educate me. Open to that as well.
Good stuff, brother. Appreciate it.
Well, thank you guys for coming. Any other questions? Dismissed? I don't know. Thanks again, guys. Hope you guys found some kind of value. I'll have the slides up on the meetup. I'll probably put a Dropbox link or something like that in case anybody's interested. And I can throw the code up there too.
I was going to ask you about iHire, if you don't mind.
Yeah, sure. Oh, I'm sorry, real quick. Is anybody here hiring that does not work at iHire? I was just like to, I use this for my own networking benefits, but I figure now's a good time if your company is hiring for any reason. Anybody hiring or have any tech events coming up soon? Anything like that? No?
There's one over here.
Oh, Christine?
I'm looking for a data analyst.
Looking for a data analyst. Okay, cool. Yeah, I had an opportunity at a recent meetup to kind of pitch some of iHire's hiring needs. So I figured I'd extend that to other folks too. So if you're want to be a data analyst, go talk to Christine.
So is iHire like